So we said in the last video that we're going to begin looking at some kind of ways of measuring perception. How can we measure perception? And we also said that there were two methods, the physiological method and the psychophysical method. And in this video we'll begin to look at I'm spelling these all wrong, psychophysics. Psychophysics. So recall that in psychophysics we are measuring the relationship between stimulus and the perception, and not the kind of physiological stuff in between. We're not really concerned with detecting from individual neurons and measuring things on that kind of level. In psychophysics, one of the main ideas to come out of psychophysics is the idea of thresholds. And there are two main thresholds that we tend to talk about, and that is the absolute threshold, and also difference thresholds. Difference thresholds. So the absolute threshold could be defined as the minimum amount of some stimulus required before you perceive it, the absolute minimum amount of something. It could be, for example, the minimum amount of light that you need before you can perceive that light, or the minimum say the minimum volume of sound that you would have to hear before you could hear actually before your brain would generate the qualia of actually hearing that sound, before you could consciously say you've detected it. The difference threshold is the minimum kind of difference between two stimuli before you notice a difference. So that could be something like, say, if we've got two pieces of string that are almost the same length, but but say one is slightly longer, would you notice the difference? How much difference does there have to be between them before you notice the difference? It's a very kind of interesting patterns. We'll look at something called the Weber fraction in the next video. These patterns kind of emerged for each of the different senses, which kind of tells us a bit about how sensitive they are. We'll look in this video at the absolute threshold. Let's get rid of that one for now. There are kind of three main methods for detecting the absolute threshold. Two of them are kind of very intuitive. We could perhaps think of these on our own. You would have thought of these yourself, and that's the method of adjustment. I would put a method of adjustment, and the method of limits, So what are these two? These two are kind of sequential methods of beginning with one stimuli at some volume and then kind of adjusting it until you reach that threshold beyond which it's no longer perceptible. So in the method of adjustment, let's say we're using the sound volume example that we mentioned a second ago. Let's say we start with some sound and we'll say it's intensity 100. This is a random number. In the method of adjustment, the subject or the experimenter would just turn a dial so that this sound volume just decreased, and they would turn it until they could no longer hear it. And you would perhaps repeat this a number of times, and let's say that on the first test they got down to kind of 85, and then beyond that they say I couldn't hear it. They stopped turning the dial there. In the second test they might turn it down to about 83, or in the third test it could be down to 91. It would be slightly different on each trial, but then you would average out those results and you would call that then the absolute threshold for hearing from experiment. The method of limits is very, very similar, except for in the method of limits it's not one trial. What we would do is begin with a sound intensity of 100 and ask a yes or no response. Did you hear the tone? Yes, and then we would perhaps turn it down by a notch or two, and then ask again, yes, okay, and then we would keep going until we get down to, say, some threshold where they would say no. And again, in each test, the no is going to come at slightly different volumes, but ultimately we would average those out and obtain what we would call then the absolute threshold. The third method is perhaps less intuitive, and it's called the method of constant stimuli. you lie. And the method of constant stimuli is similar to these, but it's considered to be kind of more accurate, but it takes a bit more time. And it's considered more accurate because it gets, well, we'll see in a second. In the method of constant stimuli, we would have perhaps the same thing, a number of different volumes that we're going to present to our subject. Let's say we've got 100, 98, 96, 90, and we let's say we've got 10 different volumes, so 96, 94, 92, 90, 88, 86, sorry, 84. Let's say, in fact, let's say that that's what we're using, and then we would perhaps in each trial, let's say we've got a number of trials, and what we're going to do is in each trial we're going to present one of these tones. Well, in each trial we'll present perhaps 5 or 6 of these tones randomly, so it immediately eliminates what has shown up in these experiments in the past, which are expectation beliefs, which is the idea that if it's sequential, you kind of know that the next tone is going to be quieter, you might try harder to listen, and so on. But with the method of constant stimuli, we might first present 100, and then 92, and then 96, and then 94, and then 98, and then 90, so that it's random. The next tone you hear is not going to be based on the previous tone, so there's no expectation. And we might get kind of yes, 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 no, no. And then in the second test we'll present a different set of 6, so we might this time present these 6, but in random order again, so we might get kind of a yes, a no, a no, a no, and a yes. And we would do that so on for the rest of the experiments. I'm just going to fill some of these in around the middle mark here. We might get a yes, we might get a no there, a no, a yes. We sometimes do get a yes on a quieter tone than we've heard a no on. That's just the way it is. We might get yes, yes, no. We might get lots of no's down this bottom end because these are inaudible. And the thing with the method of constant stimuli is once we've completed a number of tests, the threshold then would be defined as the volume intensity which is perceived about 50% of the time. So down at the bottom end, we're just getting no's for most of the time. We might have a yes, let's say we've got a yes on one of the trials, but it's rarely ever perceived at this intensity. So the absolute threshold would be the threshold, the intensity at which it's perceived perhaps 50% of the time. So we've got 3 no's on this one and three yeses. I've actually written more than that, but that'll do. So if we had 3 yeses and 3 no's, then that would be 50% of the say that this is our threshold. Even if we've had 1 or 2 yeses below that threshold, this is the way that the method of constant stimuli defines the threshold. So that's the kind of the basic idea of thresholds and some of the ways that we can arrive at thresholds, and we'll see this cropping up as we begin to look in depth at the senses and at some of the experiments that have actually been done to detect these thresholds, but I just want to introduce you to that. In the next video we'll look at the other one, which was, if you remember, the difference threshold, and we'll look at things that have come about from that, which are again very interesting.